I ain't understand it. So.
All right, no, and see that's exactly my thing. This is exactly my thing. I don't want people to be like they don't understand, or you know what I mean, and we blown past people because you see, I want to take my time to make sure people get it. Number 4, that's the division problem. All right. Okay. All right. So I'm gonna break that down like this. It's 9. What's it? 9 and 1/4.
It's 9 divided into 1 and 1/4.
Oh, so it's 9 divided by 1 and 1/4.
What page is that? 597.
I'm putting it up on the board, so. All right. So, first thing that we got to do, guys. First thing you got to do with this situation is you want to make that an improper fraction. All right. So, how are we going to make it an improper fraction?
4 times 1 is 4 plus 1 is 5.
All right. All right. So I'm gonna just work this over right quick. So we got 9 divided by 5. Wait. Yeah, that's right. Divided by 5/4. All right. And what we did was 4 times 1 is 4, and then you got the 1 remainder, so we adding that. All right. Because really, that's really 4/4 plus 1/4, which gives us that 5/4. Because remember, 1 is any number over itself. All right. So I'm just throwing that in there to get you a little treat while we're doing this thing. All right. So let's get it. All right. So this is division. Now remember, I keep telling you, division is the opposite of multiplication. So that's why we have to do that inversion. Right. All right. So that's what we're going to do. So once we change the sign, and remember, any number by itself is over 1. So once I change the sign to that, I'm going to flip this because I changed the sign. All right. All right, so now, what am I going to do now? All right, so now we could just straight.
So you just split it just because it's a multiplication sign now, and that's an improper fraction.
Right. So because remember, division is the opposite of multiplication. So since this is division, we're going to invert this and flip it because it's the opposite.
Okay.
Just let me just show you like this. If I can share another example with y'all. If I got 9 divided by 3, all right? If it's not, let's say it's 9 divided by 3. All right, just to show you that this really works. All right, so then it's 9 times, then we gotta make that reciprocal. What's that gonna be? Sharia, student of the month, reciprocal.
3.
It's going to be, what's it going to be?
3 over 1.
It's already 3 over 1. It's going to be 1 over 3. Right, because we're flipping it. It's already, all these numbers is over 1. Remember I said any whole number is over 1. So once you flip it, now it's 9 over 3, which equals 3. 9 divided by 3. Right. So I'm just showing you, so this thing about the reciprocals and all that works. Because you see it works. Because we already know 9 divided by 3 is 3. So I just use that to check and to make sure people know. So when we do that and change that thing over, it's still the same. Okay, because division is the opposite of multiplication. So when you do the opposite, it's going to work. So now, getting back to this. We're trying to figure this out, and this one is a problem. All right, we started with 9 divided by 1 1/4. So now we did our flipping, our inversion. That's what it's really called. So now we're going to just multiply. Jackie, how much is 9 times 4?
36 over 5.
36 over 5. All right. Now 36 over 5, we have to reduce that, or we have to convert that, because that's an improper fraction. What are we going to change that to? What can we change that to?
Can you take away 36 over 5?
Say it again.
Can you take away 36 over 5 like you did yesterday?
Oh, no, because see, you know what? If these numbers were closer, I would do that. But I can see that this number here is divisible by 5. How many times does 5 go into 36? 7 times. So I'm gonna put down here 7, and what's left over? 1. And that should be the answer, 7 and 1/5. So that should be the answer.
I got it.
Okay, I'm just saying.
I did get it after a while.
Yeah, but and see, that's what I'm saying. If you know, a lot of things it might take us a little more time to get stuff, but if we stick with it, it's going to come. You just can't say, you know what I mean? You got to stick with it. Stick with it. All right, what's the next math problem? You got another one?
5 1/3 divided into 4/15.
All right, am I in there? You see me?
Yeah.
All right. All right, so this is...
Hold on. I got
That's
it.
number 2.
This is number 2?
Yeah.
All right, so we're going over these. Are these, do you understand these? Is this helping you as well?
I'm understanding it now, yeah.
Okay, that's what it is. And Jackie, you have any problems with these fractions?
No, only the one that you say, number 2.
Number 2, you got a problem with that one? All right, well, let me look at number 2.
Yeah, because at first I didn't understand where 20 came from. Like, how did that?
Look, number 2, wait a second. Number 2 is a problem. And so you know what? So it's 5 1/3. 5 1/3 divided by what?
4/15.
4/15. All right. I can work with that. A little bit. All right, so let me ask Maria. We're going to start with you, Maria. What are we going to do first? What do you want to do first?
I don't know. Do you bring down the 5? No, you multiply 5 times 4, no?
Oh, no, wait a second. What do you want to say, Shamir? What are you thinking?
The 5 1/3, convert that, and which is 5 times 3 plus 1, right?
That's right. All right, so when she's saying convert, she's talking about making that mixed number, all right, and the mixed number into an improper fraction. So 3 times 5 is 15, plus 1 is going to be 16 over 3. And that's going to make our life a lot easier. All right? It's going to make our life a lot easier because now when we change this to multiplication, this 4/15 is now going to be
15 over 4.
15 over 4. All right. Now this is nice and smooth. It's nice and smooth for you now because I don't know if you can see there's a relationship to the numbers that form that X. All right, and that's going to make it easy. Because some people would just say, I'm just going to multiply 1,000,000 times 2,000,000 and get, you know what I mean?
That's what I was doing, but I got what you were saying yesterday, how you cancel like 3 times, go into 15 5 times, so you would cross the 15 out and put the 5.
And how many times does it go 3 going to 3?
1.
Okay.
Then you would cross the 16 out and put the 4, because 4 going to 16 4 times.
Exactly. And how many times does 4 go into 4?
1 time.
1.
And then you divide it like that.
And then you're not divided, now you multiply
times
it.
it, yeah.
Multiply it. So now, you got something nice and easy, 20. So that's when you said you don't understand, you got the 20, now you...
But I was putting the 1 under it, like where the hell they get 20, where's the 1? And then he was like, anything over 1 is itself. So then I figured it out, like, oh, okay.
Okay. So that's cool. So that's 2 problems down. All right, we're gonna do, so this is just the homework that we're basically going over the homework from yesterday. All right, so we're not moving on into the. We skipped the first. Is that what happened? We skipped the first one.
But the first one I got, so it was easy. So.
You got the first one. Did you get the first one?
I mean, I wasn't here yesterday, but.
All right, well let's get it. You know what I mean?
I mean, I'm not good at that.
But listen, and let me tell you something too. Here's the thing.
And they give you videos and how they say it, and you just sitting there. that's what I did. I went on the internet and then my boyfriend helped me. So
Yeah.
the internet, they explain and it be slow. You like, you gotta understand that. He be pointing at the thing, it's like, and you do it like this. I mean, when they say step by step, it's actually like step by step. So it helped me a lot because before I didn't understand like how he just was cross canceling it out yesterday. I'm like, what the hell is it? That's where I was getting lost at.
Yeah.
Then I was like, oh, okay, I see what he's doing because that man is so you like, you have to understand, get this man off my TV.
Okay, all right, so now look. So we want to make sure that everybody's getting this. So we got 3/8, right? 3/8 divided by, what is it, 3/4? All right, so the first thing, what's the first thing we got to do?
Flip,
All right, so we got 3/8, and it's going to be times 4 thirds. So you see automatically once we do that, Jared, what's the next move? You said you got to multiply? Okay, let me see. You do have to multiply. That's my lunch up in there.
Answer 2, right?
So, like 3 times 4.
What you say, Chris?
The answer 2?
You said it's the answer 2?
Yeah.
I don't think the answer's not gonna be 2. Because the first thing, I'm looking at it, you know, I mean, I got superpowers and stuff, so I'm looking at it different than y'all. All right, but the answer's not gonna be 2. First thing you would want to do is this. You see these 3's, right? Cross them out, and then what you gonna do with the 4, Takia?
it's gonna be a 2.
So 4, first you're gonna say 4 goes into 4 one time.
Oh yeah, it's gonna be a 1.
4 goes into 8
2 times.
2 times.
That's gonna be a 2.
So when you talk about it's a 2, it's actually 1/2. 1/2. And which is kind of cool because if you look at this,
I ain't do mine like that. I did multiply mine out.
or you just multiply the whole thing out. I want to do it that way because that's going to give you.
Because I didn't, yeah.
Okay, I do it that way too because the answer I do it right here.
It's 3 times 4 is 12. I did that. It did like that.
Exactly.
And see, you know, because I was looking at this and I said, what I did wrong.
I said 24 going to 12 going to 24 one time and 12 going to 24 2 times.
Right.
So that's how.
Yeah. And so either way, if you break it down or you don't break it down, it's going to be the same thing. Either way. Maria, you looking? All right, want me to do it again?
No, like, I don't get, like, the part where you have to, you know, cut the number and add it.
Okay, well, no, let's do it. I'm going to do it again. I'm going to do it again because I want you to get it. All right, so look. So again, we got 3/8. I'm going to have to get another marker. Let me get another marker. I don't want anybody to have any problem with seeing anything. All right, hopefully this one's a better marker. Yeah, we got a better marker. All right, you ready? So we got 3/8 times 4/3. All right. Now, the thing is this: the reason why you can cross divide is because it's not changing the number when you do that. Fractions are the same if you're dealing with the same number. All right. Let me show you what I'm talking about. For example, 4/4. 4/4 is 4 divided by 4, which equals 1. So if you multiply, 1 is the identity element of multiplication and division. So no matter what you multiply by 1, the answer is going to be whatever that number was. 10 times 1 is 1. 20 times 1 is 1. 30 times 1, no, I'm saying anything wrong. 10 times 1 is 10. 20 times 1 is 20. 30 times 1 is 30. All right, I'm glad I caught myself. All right.
Division.
Right, division. But anything, and look, but even with division, it's also identity element of division because 10 divided by 1 is 10.
I was about to say.
I know, that's how I caught you. 20 divided by 1 is 20. 30 divided by 1 is 30. It's the identity element. So when we're doing this, when we're breaking these numbers down, that's just when I'm crossing these numbers, I'm saying how many times does 3 go in here? That goes 1 time, 3 goes in here 1 time. All right, I'm really dividing, by doing that, I'm dividing by 3 over 3, which is 1. So 3 goes in that 3 1 time, 3 goes into that 3 1 time. So that's what we're doing when we're doing that cross multiplication. The same thing when I say 4 goes in here 2 and 4 goes in here 1. I'm really dividing by, I'll put it over here. I'm dividing by that. All right, 4 goes into this 2 times and 4 goes into that. So I'm not changing the value of what it is. I'm not changing the value of the number because anything multiplied 1 is going to be the same. Anything divided by 1 is going to be the same. So we're not changing the value. We're changing how it looks. See what I mean? We're not changing the value. We're changing how it looks. I'm going to be me. I might put on a different suit. You might change how I look, but I'm still the same person. All right? So you can multiply me by 1. I'm not changing. I'm changing. My appearance is changing. All right? The way this number looks is changing. All right? So 1/2 is looking different, and this
1/3. No, 1/1.
right. So it's looking different, but it's still the same thing because we see if I multiply it out, 3 times 4 is 12, 8 times 3 is 24. That's still 1/2. This is still half of 24. That's still 1/2. If I work it out and I cross this out, 3 goes into 3 once, 3 goes into 3 once, 4 goes into 4 once, 4 goes into 8 twice. That answer is 1/2. So it's not changing. The way it looks is changing, but the value is still the same. Okay? All right. Moving right along. So we did all of these except the 26 over 5, right? 26 divided by 2 over 5. Can I do that one now for y'all? Jared, you want to help me with this one?
Yeah, I guess.
All right. Jared said, yeah, I guess I can help my brother out. All right, look. So we got 26 divided by, what is it, 2 over 5. All right, Jared, what I got to do?
You gotta,
Somebody must be stealing my markers. Huh?
I'm gonna find the note.
Okay, that's all right. That's all right.
I don't know neither, but I'm about to ask. Would you have to make
Although you want,
put the 26 over 1, or would
Right. Yeah, 20, you can do that if you want.
but that don't look right.
Mm-hmm.
26. That's like 2. We talking about music. That look like a B flat. I'm in the music mode. 26 over 1. Go ahead. And then what else we got to do?
Put the times sign, flip it,
Top
5 over 2.
multiply.
Okay. All right. Now is this something we can do before we multiply?
I guess you could.
Change that improper fraction or leave it.
No, that's good.
I cross cancel.
The 26.
The 2 going to 26 13 times.
All right.
So it'll be 13 and that'll be 1.
Right.
And I left the other one like that.
All right. So now, 13 times
5,
is
65.
65. And that's the answer.
Well, I put a 1 under it, but
Yeah, but you don't need a 1 under it because it's standing by itself. What's wrong, Maria?
No, it's still the same. Like,
Yeah, what's that? 65 over 1 is still the same thing. Because anything, you know, anything divided by 1 is still itself. So that's what we're working with. Anything divided by 1 is still itself. All right, so any questions or problems about what we went into just now? All right. Jackie, you have any math problems in there that you never got the answer
That
to?
was the one that I was going to ask you, number 3.
All right. I did it for you? Are there any other problems, perhaps, that I need to look at? Because, you know what I mean, I got a whole schedule of stuff to deal with y'all.
660.
Don't say 666, because that makes me nervous.
No, I don't like that.
I like that.
So,
You like that number?
Yeah.
I know there was something funny about you.
And this right here helped me too.
What's that?
The operation with the fractions. With the add and subtract, the denominators must be the same. The multiplying.
Okay, all right.
That helped me too.
All right, yeah, because I kept saying that, right? I kept saying it. The lowest common denominator, I was telling you, that's the word of the day when you're dealing with fractions, lowest common denominator. But you only need that with adding and subtracting. Multiplication, division, you don't need that because multiplication and division is the same thing. But when you add and subtraction, you're going to have the same thing. And remember when I did that pizza pie? When I broke that pizza pie down? Did you get the pizza pie thing? You didn't get the pizza pie? Huh?
What pizza pie from yesterday?
Yeah, did you?
I wasn't here.
No, before. I did it before. You didn't get the pizza pie before? Let me break it down for you one time. The pizza pie. Who likes pizza? You like pizza?
Yeah.
All right, I'm gonna get the pizza. I'm gonna get how many people we got in here? Do we got enough people? All right, well look, you know what's funny? This is crazy because we got enough people for us each to get a slice. All right, we got enough people for each to get a slice. But you know what my problem is? I'm gonna buy a pie, but look, I'm gonna eat half of the pie. I'm gonna pay for it. I'm gonna eat half of the pie. Y'all got a problem? I'm gonna eat half of the pie. All right? You look like you could eat a quarter of the pie. You can eat a quarter. And then my 2 video vixens, I gotta get them a slice each. My 2 video vixens is getting a slice each of the pie. Now what do we do, Takia?
Make all of the bottom numbers the same.
Okay, and what number you think is going to be good for all of them?
8.
8, because that's what a piece of pie is. 8 slices. So 8 is the common denominator, and that's what that's what I'm trying to help you think about. When you think about all this math and stuff, think of the piece of pie. And when you think of that common denominator, you're thinking of how many slices can you cut something in so we can all work with it. That's what it is. How many slices we can all work with. All right. So Maria, if I want to make this into 8, what do I have to do?
The answer is 1, right?
Wait. What I got to do with this to make this 8?
Times it by 4.
Times it by 4.
And then the top turns into a 4.
All right. All right. So let me let Jackie answer this one, Chris. No, this is all addition. Jackie, what do I have to do to this one?
4 times 2.
4 times 2 is 8, and then it's 2 over the top. Again, look what we're doing. With this one, we multiply that one by 4 over 4, which is 1. With this one, we multiply by 2 over 2, which is 1. And with these two, they already have what we're looking for, so we don't have to do nothing with it. All right? So, this is breaking it down. When I buy this pizza for us, or for me, I'm going to have 4 slices, which is half of a pie. All right? Since he's sleeping, I'm going to give Chris his 2 slices, which is a quarter of a pie. And then we got the video vixens. They get a slice each. But you know what? Since y'all here, I'm going to get y'all pie too. I'm going to get you know what? I'm going to get y'all pie. How many slices you going to eat?
I can eat half too.
She can eat half? Okay. All right, so look. So she's going to eat half a pie. So then I guess Jackie's going to eat a quarter. And Jared's going to eat a quarter. Now, Takia, since you're eating most of the pie, How many slices are you eating?
4.
4, which is half of the pie, 4 over 8.
Not to say, I know, but
Say it again. What you was gonna say?
there's 8 slices in a pie.
Right. So eating half, that's 4 out of the 8. Right. So, Jackie, how many slices are you gonna have?
That'd be 2, 8.
All right. She's having 2 out of the 8. And Jared, how many slices you gonna have?
2.
All right. We're gonna make this happen. I'm gonna make this happen for y'all. You're gonna come in one day, and you're gonna say, "Oh, you wanted 5? Oh, no, you didn't." I'll be like this. Oh, what's some here? All right. I'm a pizza man. I like pizza. No, I'm lying. I love pizza. All right. So all these things equal 1. All right. All those things equal 1. So whenever you're thinking about fractions and the common denominators, think about the piece of pie
Told you I was there.
that Mr. Swann is going to get y'all eventually. It's not going to happen today. I gotta run out of here and I gotta deposit $400 in a friend of mine's account. So that's your pizza money. I'm sorry, but the next time I got you. All right. So what was the question, Jack? Did you have a question? How did I get into this? We had something. Somebody had a problem with something. Maria?
No, she was just, you asked her what she did for the pizza pie situation.
Oh, that's what. Okay.
And you was just explaining that.
Okay. So now, if anybody offers you pizza, you can tell if you want a half, a quarter, an eighth. All right. Now I'm just curious about something. Since we on this situation with the pizza pie, suppose there was only 6 people with the pizza pie. All right. Suppose we cut it into 6 slices. All right. We got a pie. We cut it into 6 slices. So you already know I'm going to have 3 of the 6. All right. Looking at Takia. Takia's thinking she's going to have 2 of the 6. Oh, wait. I'm making it too easy for y'all. I did it wrong. We're going to give Maria 1 slice out of the 6. Takia is going to have 1/3. And then me, I'm going to have 1/2. Now the question for the day, how many slices is Takia going to have?
Which one's here? The middle?
The one in the middle is Takia. How many slices is she going to have?
So,
She's going to have 2 slices. That's good. How'd you do that?
I'm saying, there's 6, so you got half, you got 3.
Right.
And this 1 out of 6 will be so much 2.
That's right. And see, that's what I'm saying. Anytime you think of fractions, think of a pizza, and you never go wrong. All right? Because I'm gonna have half the pie. So if there's 6, half of them is 3. So that's good. All right? She's gonna have 1/3 of the pie. All right? But you said he went. I had 3. She's having 1 out of the 6 slices. So that leaves 2 slices. And the thing you gotta look at too is that 1/3, even though that number is half of that number, that slice is twice as big as that slice. With fractions, the smaller the number, the bigger the pieces. All right? The bigger the number, the smaller the pieces, because that means you're cutting that pizza up. If I had that 8, that same. Okay, but let me ask you a question. I'm gonna ask Maria a question.
Ay, Dios mío.
Now look at this. I want to ask you, which one of these are bigger? Which one is bigger? And tell me why.
What the hell you see 1/2?
Oh wait, I thought we were looking at that one.
1/6 is bigger, why?
Because you said that's more.
Right, and then I'm saying, if we dealing
That
with,
one is only what? Two slices, 6. The 6 is bigger, of course. The
Right.
person is gonna have.
because the trick is, the reason why it's bigger is because you got the same pizza with less cuts. So the slice is going to be bigger. You see what I mean? And because when you got a regular pie, look, I'll just show you like this.
Slices.
I'll just show you like this. I'm going to try to make these both the same size. They're pretty much the same size. Now look, for the 6 one, it's going to be all right, you see how big those slices are? With the 8 one, so it's you see the 6 one is a little bigger. And you can do that again by doing this common denominator thing. What would be the common denominator between 6 and 8?
24.
No, 24.
24. That's good. You should die for that, man. Is this thing we still taping? What? Am I in here? Am I in here like this?
Yeah, you good.
The chicken like you see up taping, flame. All right. All right, well, look. The thing is, you said the common denominator is 24. All right, and so that means to make 6 24, that would be multiply this by what number?
6 times what equals 24.
Right, 6 times what equals 24?
3.
No.
No, 4.
4. So that would be 4. Be 4 24s. To make 8 24, we're going to have to multiply, Jackie.
8 times 3.
8 times 3. So you can see, if we had 24 slices, you get an extra slice with this one. Or you can see that this is just the slices with the 6 or just a little bit bigger. What's wrong, Maria?
No, I'm listening.
Huh?
I'm listening. It's just
No, I was saying something like this. Are you allergic to pizza? She's like, ah.
No, I'm thinking like, I'm telling you, like, even though if you explain it to me, like, I don't know.
No, what?
I get it, but at the same time, it's like I forgot about it, you know.
No, it's not a problem. What I'm showing you is this. You see how I was saying if you cut it in 6 slices, these slices are a little bigger than this one.
Yes,
You see that? These slices are a little bigger. All right, because this was in thirds and then 6s. This is 8. We got the same pizza. If you cut 6 slices, those slices are not going to be the same size if you cut 8 slices. Because the 8 slices is going to be a little smaller. All right, because you got more slices with the pizza. And that's why the higher the number is, like it's going this way, the higher this number gets, the smaller the pieces.
Okay.
So, can you open that door, please?
No more, honey.
Now you like the dog?
No, I don't like the door. They got the door locked. I think they got the door locked because they mad about me getting pizza. Oh, you missed the pizza.
Pizza.
Yeah, we have pizza.
Early that morning?
Yeah.
Wow.
But so, yeah, she's good. She's good. But you missed the pizza though. But we get you some later, okay?
That's what you have been doing all morning, Matt?
Yeah. We started with some. We started with the ELA, and then we went to math, and then if we don't have any questions or problems about math,
We going on break.
oh, you haven't taken a break yet?
Yeah, we did, and that's why I said I'm going to.
Okay, all right, that's what's up. That's what's up.
You know, teacher, I didn't put my phone on.
I'm gonna break.
I put it at 9. I bring my baby to school at 9.
School?
We gonna
You
break
want to go to
out.
school late?
They say why I'm so.
Oh, let me stop this. Do you see what I'm doing, Fab?
Oh, you